Hello everyone. In this tutorial, we will analyze and visualize a dataset using Seaborn library. So as you can see, Seaborn is a Python data visualization library based on Matplotlib. So it provides high-level interface for drawing attractive and informative statistical graphics. So it's very helpful if you want to visualize your data more informatively and more statistically. So it's very useful library. So what we're gonna do, so this is our data set. So it is the automobile data set. So as you can see, so it has a large number of data, and different columns are make, fuel time, aspiration, number of doors, body style, drive wheels, engine location, wheelbase, length, width, height, curve weight, number of cylinders, and so many different columns are there. You can see in the data: engine size, fuel system, bore, stroke, compression ratio, horsepower, peak rpm, ctm, pg, highway, mpg, and price. So we will analyze this data set, we will visualize this data set using Seaborn library. So first of all, just go to the Google Colab, and first of all we will go to the files and we will upload this dataset into the session storage. So just click here and I upload this dataset into the session storage. And then here, from three dots, just select the this option, copy path. And so just select this copy path, and now I will close this. So what I'm going to do, I will import pandas as pd, I will import this library Seaborn as SNS, I will import matplotlib.pyplot as plt, and I will set the sns.set color code equals to true. It means Seaborn now will support assigning colors to the plots using matplotlib color codes. So first of all, let's run this cell. So now I will import my data. So my data is in the CSV format, so I will use read underscore CSV file. So I will paste the path here and just run this cell. So now I will print this data. So let me print this data auto. So here you can see there are 205 rows and 23 columns, and if you want to print only particular rows, so auto.head, and it will print the first 5 rows of your data set. So my data has been uploaded. So data has been uploaded, and this is the data frame. Auto is the data frame. Now I will use this data frame auto to visualize my data using SNS. So now I will show how distribution of data, how you can view the distribution of data for a single variable. So distribution of data, it will work only for numeric variables. So there are some numeric variables like this. These are the numeric variable, and there are some categorical variables. So distribution of data will work for only numeric variable. For that, I will use SNS dot this distribution plot, and here I will pass the variable. So I will pass this variable engine size. So I will pass this, and then I will use plot.show. So just run this code, and you can see, so you can see the distribution plot for the engine size. So where you can get an idea of how the data is distributed for the engine size. So similarly, I can show the distribution plot for wheelbase. So this is the distribution plot for wheelbase, and on in the x-axis there is a particular variable, that is wheelbase, and on the y-axis there is a density. and then I will show the distribution plot for the horsepower. So this is the, you can see x-axis there is horsepower, and on the y-axis there is a density function. So I am showing how the data is distributed uh, for the horsepower. And as you can see in this graph, uh, on the right side there is a kernel density, and if you don't want to see this kernel density, as you can see in the previous graph, in the x-axis there is a variable horsepower, and on the y-axis there is a density. So I don't want to show this density. For that I will, what I will do, I will just use KDE equals to false. KDE means kernel density equals to false. So let me run this, and now you can see there is no density on the y-axis. So it is showing me the distribution of the data, but it is not showing me the kernel density on the y-axis. So far we have analyzed only one variable. So we have discussed the distribution plot, so right now for only one variable, and now we will analyze more than one variable. So we will draw bivariate plots. For that we will use joint plot. So as you can see, so I will create a joint plot, and data is my data frame, and on the x-axis I will draw the horsepower, and in the y-axis I will use the engine size. So let's run this code. So as you can see, on the x-axis it is the horsepower, and on the y-axis it is the engine size, and it is a joint plot, and you can see the horsepower on the x-axis and the engine size on the y-axis. So this way you can create a joint plot between two variables. So simply use data frame, and then what variable you want on the x-axis and what variable you want on the y-axis. So another one is I will create joint plot between horsepower and engine size, but hue will be fuel type. So first of all let me run this code, then I will explain what do you mean by this hue. So just run this code, and you can see the horsepower on the x-axis and engine size on the y-axis as it was in the previous graph. Horsepower on the x-axis and engine size on the y-axis, but here I am using additional feature hue fuel type. So it will create two colors fuel type. Actually we have two values in the fuel type, one is gas and one is diesel. So it will divide the data into the gas and diesel, and it will show you the you can see the points on the graph. So you can see, you can clearly visualize what points are of gas and what points are of diesel. So this way you can use another feature hue, and it will create different colors for each of the type, each of the fuel type. So let's create another graph, and same I will use horsepower on the x-axis and engine size on the y-axis, and now I will use hue equals to body style. So let's run this code. So in the body style we have five values: convertible, hatchback, sedan, wagon, hardtop, and it is showing horsepower on the x-axis and engine size on the y-axis. And you can see the five different colors for the body style. So blue color for convertible, orange for hatchback, and different colors for different body style. And you can also see the scattered points on the graph. So it's very easy. You can simply use a data, and then x-axis, then y-axis, and then you can use the hue, and you can give any variable name here. So it's very easy to create the joint plot. Next we will create a joint plot between horsepower, engine size, and this type we will use a kind equals to histogram. So when you run this cell, so you can see that type of the chart is the histogram, and you can see on the screen. So first of all, it was a scattered graph by default, and now you can see the points like histograms. So this way you can change the kind of the graph. So all the remaining things are the same: data frame, then I am using x-axis, then I am using y-axis, and then kind I am using histogram. So another kind is you can see the regression type of the graph. So when you run this cell, everything is same, data is same, x-axis is same, y-axis is same, and now I have changed the kind of the graph to the regression graph. And you can see the x-axis horsepower, y-axis engine size, and you can see the scattered points. But this time you can also see the regression line. So it's very easy if you want to analyze your graph regression wise. So this is the regression line. So you can see the predicted point and the the actual point. So it's very easy. So this way you can also create the regression line. And next is I am using data frame auto, x-axis horsepower, y-axis engine size, and this time I am using kind histogram, and I am using hue engine location. So when you run this cell, and you can see that we have two values for the engine location, front and rear, and it is showing you the same graph, horsepower, engine size, and this time hue is engine location. And this way you can analyze. So we have only few values for the engine location at the rear, and you can analyze. The horsepower is 200 and engine size is 200. So this value lies in this category. So this way you can also use the hue. So you can mix these variables. You can use x-axis any variable, you can use any variable on the y-axis, you can use hue on the any variable, and you can use the kind of any kind of the graph. So for analyzing, for visualizing your graph in a better way. And next I am using horsepower, engine size, and now the kind of the graph is a hex. So when you run this cell, and you can see the kind of the graph is hex. I have not used hue in this. I have not set the hue to any variable. So in the next I am using kind KDE, kernel density, and hue is fuel type, and same variables I am using. So you can see the KDE type of graph, and fuel type as I have already explained has two values, gas and diesel. And so this graph again is very helpful. So it depends upon you which kind of graph you want to use, which variable you want to use on the x-axis, which variable you want to use on the y-axis. So this way you can create a joint plot. So the next type of plot that we will use is the pair plot. So we have used joint plot, and it's useful when you want to analyze only two variables. One is on the x-axis and one is on the y-axis. So joint plot is very helpful. So next type of plot is pair plot, and it's very easy to use. So it is used for analyzing the multiple variables. So here I am using pair plot, and I am passing three variables: horsepower, engine size, and city mpg. So when I run this cell, you can see 9 graphs has been created. So horsepower, engine size, and city mpg. You can see horsepower, engine size, and city mpg. And so consider this graph. So this is the graph between the engine size and the city mpg. Consider this graph. So this is the graph between the city mpg and the horsepower. I have used only one command, and it will analyze all the variables. So it's very useful, you can see. So I am passing just three variables: horsepower, engine size, and city mpg, and it is creating a different graphs. So consider this. This is the graph between engine size and the horsepower. So this is the graph between the city mpg and the engine size. So this is the scatter graph, and the between the horsepower and this there is a bar type of chart. So our other charts are the scattered charts. So it's very easy to create a pair plot. So I have passed only three variables. Next I will change the variables. So I am be passing horsepower, engine size, and this time I am passing peak RPM. So peak RPM, now let me show you the data first. So this is my data set, and you can see this column peak RPM. So this is my peak RPM, and when I run this cell I will again see 9 graphs. So you can see horsepower, engine size, and peak RPM, horsepower, engine size, and peak RPM, and there are the graphs between each pair of the variables that I have provided. So pair plot is used to create a plot for each pair of the variables that I have provided. Next I am passing four variables: horsepower, engine size, peak RPM, and city mpg. And again I am using pair plot. It means this time it will create 1 2 3 4 16 graphs. So when I run this cell, so just wait while it is being executed. So you can see the 16 graphs on your screen. So only one command is used to analyze all the variables in a pair. So I'm providing horsepower, engine size, peak RPM, and city mpg. Horsepower, engine size, peak RPM, and city mpg. And see, all the variables are on the x-axis and all the variables are on the y-axis, and there is a graph between each pair of the variables. So it's very helpful to use pair plot if you want to analyze your graph, if you want to analyze your data set between any pairs.